Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 75. And today we're going to be talking about the Outbox Pattern, for which I'm joined by Tomek Masternak and Szymon Pobiega. Have I pronounced that correctly?
Yes, correct.
From the NServiceBus team. So welcome to the show.
Thank you.
Thank you for the invitation.
So could you both introduce yourselves to listeners and just tell us a bit about what you do?
So maybe I should go. I will go first.
Yeah, you go first.
Okay, perfect. So as you mentioned, together with Szymon, we are at NServiceBus, and we are working on distributed messaging systems for at least 10 years now. We are working with a bunch of clients and in various domains, looking at how people implement their system based on messaging and also what are the common problems that they have. So yeah, messaging space, basically.
Okay, to add to what Tomek said, yeah, that's also 10 years, more or less, in the messaging space. When I joined the company, the Outbox pattern that NServiceBus has just been released. So it's kind of my career at the company is correlated with the existence of that implementation there. So I feel like some special connection to the pattern. And last, I think, 5 years, I was more focused on trying to find better ways of deduplicating messages.
Nice. I know when just before we started recording, we were saying that the Outbox pattern seems to have been something that's just gained popularity quite recently, like more heavily. I kind of like guess that it might be content creators are taking it more on board, so that's then bringing it back into popularity. But before we actually dig into the Outbox pattern and actually explain what it is, just a few small reminders to the listeners. So firstly, this podcast has its own Discord community. So if you head over to the website unhandledexceptionpodcast.com, you'll see a Discord link there. Also, I have a monthly newsletter where I send out handpicked developer news items from the past month. It also includes a dev tip and a dev comic pick, as well as podcast updates about the show. So if you want to sign up, there's a subscribe link on the podcast website. It's basically a great way to keep up with developer news, especially in the .NET space. And lastly, a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. So the Outbox pattern. So for time's sake, I think we need to assume the listeners are already familiar with the concepts of messaging and message brokers. So that means we can focus just on the Outbox pattern itself. We've had quite a few episodes on messaging in the past anyway, so I think they're all tagged messaging, all the past episodes, but before releasing this episode, I'll make sure that all past episodes about messaging are tagged with messaging so you can find them quite easily. So let's just dive straight in. What is it best to talk about what problem the Outbox pattern is trying to solve?
I think so. Yeah, I think that's a good angle. So maybe we can go with that first. So you mentioned then that for some reason the Outbox pattern gained popularity recently. But I think that the moment at which, from the technical perspective, it became interesting, important, and more heavily used was, and Szymon, please correct me if I'm wrong, when people started moving to the cloud infrastructure. So if you look at the messaging systems, those were around for decades now. And people were working with it. And very often the endpoints or some processes that were working on top of the messaging infrastructure worked in such a way that they would consume some message, make updates to the database, and publish or send some other messages. That was a very common pattern. And it wasn't very challenging from the technical perspective because there was something which was called distributed transactions. So the messaging infrastructure would be MSMQ, IBM, TIBCO, you name it. There would be some kind of a SQL database, and there would be a distributed transaction that would span and glue together all of those operations. When the cloud came in, one of the messages or one of the arguments made for cloud infrastructure was that in the cloud, you can't really have such a strong guarantees. That's why there are no distributed transactions. And you need to figure out how to deal with some potential inconsistencies in your messaging and database processing logic. So I think that at that point, there was a shift in the industry or shift in the environment when some transactional guarantees that previously were taken for granted were no longer available. And this is where the Outbox pattern came on the stage, basically. So I think that was that turning moment probably 15 years ago or so.
So quite often when I read about the explanations of the Outbox pattern, the typical kind of example that people give is maybe an order system creating an order in its own business database, create an order entity, like a business order entity, record in SQL or whatever, but then publish a message saying, basically broadcasting to the system, an order's being created. And from what I understand, that's the problem it's trying to solve, where that database where you're writing the order to the business database succeeds, but then there's a network issue, and that broadcasting to the rest of the system that an order's been created, that fails. So basically the whole system's misaligned because there's an order in the database, but none of the rest of the system know about it. So maybe for an order, emails haven't been sent or payments haven't kicked off being processed and that kind of thing. Have I kind of explained, is that the crux of what this is trying to solve?
Yes, I think you explained it very well. But the funny thing about the Outbox pattern is the way, at least it's most recently described, is you can get to it in two different ways that we realized recently that are different ways, and some of the misunderstandings that I think crippled the pattern for quite some time, or crippled the adoption, came from the fact that many people understood or came to the same pattern different ways, emphasizing different things. So what you emphasize is when publishing a message and updating state, you want to have these things atomically done because you don't want to have what we call ghost messages. So a message goes out, there's no update in a database that corresponds to that message. So the message says the state has changed, the state has not changed. That's immediate inconsistency, not even eventual consistency. It's much worse. And then the opposite is you say store the data. The message did not go out, so it's basically pointless. The business process is stuck in that place. But this, one could argue, can be solved by arranging the operations in such a way that first you store the data and then you publish the messages. And if you fail to publish the messages, then hopefully there is some sort of retry mechanism that will kick in. The message will go back to the queue, the initial message that caused that business transaction, and the message will show in again, and then the business logic needs to figure out, oh, did I save the data the first time I attempted to process the message or not? Potentially save the data again if it's not saved, and then republish the message. So this could be solved, but then you could argue that, well, you need to publish exactly the same messages as you attempted to publish the first time, because if anything changed in the database between these two attempts, then you might publish different messages, and the recipients might get crazy because you can have the contradictory state being advertised through those events. So this is, I would say, the approach of Outbox, where you get to the Outbox by insisting that you need to have consistently published messages, but you can also get to the Outbox by saying, oh, I need these to be atomic, and not even go into trying to go around it. So either way, you get into that pattern, and what I think is important to state is the Outbox pattern is, in context of messaging, is incomplete without deduplication in place of incoming messages. So when people come to the Outbox pattern from, let's say, the web API context, the most important thing in the Outbox pattern is I want to atomically save the data and publish messages. And if anything goes wrong, the user will see it because we will display the yellow screen of death or something more user-friendly. And then they can go refresh their browser window and figure out if the data was saved. If the data has not been saved, then that means the message did not go out. So that's kind of user handles these corner cases. But in the context of asynchronous messaging, there is no user that will handle these cases. So you need deduplication in place, because the fact that the Outbox stores messages and then tries to publish them to the broker means that it might do it multiple times. If it does so multiple times, then there are multiple copies of the message on the wire that will hit the downstream service. So there is no Outbox without deduplication.
And maybe to add just additional context to what Szymon mentioned, which I think might be good to make sure that is clear, is that there are actually 3 operations that are happening for each message. So it's receiving the message, updating database, sending outgoing messages, and then acknowledging the incoming message. So the assumption behind the Outbox pattern is that you have at least once message delivery guarantee from the messaging system. So until message is acknowledged, it's going to be redelivered by the broker at least a couple of times. So no matter where the processing fails, whether it's before storing into database, after storing into database, after sending the outgoing messages. If the message is not properly act or not act in time, then broker is going to redeliver it. And then the question is, when the message is redelivered, because your system has to be prepared for that, how do you make sure that the outgoing messages are still the same as the ones that were published in the first place? So in the example that you were giving then, like if you have an order and you're sending some information about the order, let's imagine that in the outgoing message you want to have the total amount paid so far by that customer. If between message retries, which can take a lot of time actually, if the message goes into the error queue, you need to fix some bug in your system, then bring the message back into the input queue. If that customer makes some other orders, those two messages are gonna contain two different values if some additional payments are done in the meantime or booked in the meantime. So that's that consistency aspect as well, which Szymon mentioned, which I think, and I fully agree, it's also crucial to the well-functioning Outbox, that you need to deduplicate messages as they come in as well.
I do feel like we've covered an awful lot then, but I don't feel we've actually explained what the Outbox pattern is. Can we just take a little step back and just, like, so the initial problem that I mentioned, where you're writing to an order to a database, but then you're publishing a message to tell the system that an order's been created, but that fails because of a network issue. What does the Outbox pattern actually look like from an implementation detail?
Okay. So maybe I can give it a go, and Szymon, please comment. So basically, the guarantee from the business perspective that the Outbox gives is that changes to the database and sending outgoing messages are going to be done in an atomic way. And the way that it's implemented is that when a message comes in, there is some logic, some business logic, which is being executed. When the business logic starts, usually you start the transaction. And I'm assuming here that we are talking about implementation over SQL database. So the transaction starts. There is some business logic which operates in your code. And a part of the business logic, there are some operations which say, I want to send a message, I want to publish a message. What Outbox pattern is doing is that those operations are not happening when they are invoked in code. Instead, the messages are piled together in memory. The business transaction is being committed, and those messages are piggybacked together inside that transaction and stored next to your business data. So in the first step, you open the business transaction, no messages get out, you commit the transaction, and at that point in database, you have both the changes that are the result of business logic plus the outgoing messages. When this is done, the messages from the database are picked up, or they are stored in memory, so we don't have to pick them up. Then they are sent, and when the sends are successful, database is cleared, so the outgoing messages are removed from the database and the incoming messages being act. So that's roughly, let's say, I think the most common implementation of the Outbox. So in a nutshell, it's about piggybacking or attaching messaging operations into your database operation and making sure that that's atomic. And then after the transaction is committed, those messages are being pushed out. And depending on the implementation, that pushing out phase can look in various ways.
So from just using an example, if you're using like SQL Server or something, and you've got a database and you've got an orders table, you would also have a messaging table, that kind of thing?
Exactly.
So your code, which would have previously published the order created message, isn't doing that anymore. It's just writing a record to that messaging table in the same SQL transaction as it's writing to your order table, so that if any of those fail, the whole thing fails and rolls back. But then, am I right that you'd have some kind of background worker or something which then takes those messaging records and then publishes it asynchronously, so that if that fails, it can retry because we've got it in our own database?
Yes, exactly. That's a good explanation. And the actual problem that we're solving here is that the messages are usually in the business code. The message generation is intertwined with business code. So the change in the database that causes these messages to be published cannot be easily decoupled, for lack of a better word, from the generation of these messages. So this is one unit, and Outbox allows this one atomic unit to be actually stored as one atomic unit, versus Without that pattern, what happens is you store the change in a database, and then you try to figure out, given that delta, that changes, what messages should be published. And that's not an easy task, especially if you take into account what Tomek mentioned, that messages might be retried after some time, and there might be some reordering happening, and there might be some other messages that are processed in the meantime. And one thing that I would like to add here that connects to the story that Tomek told in the beginning is, for quite some time, there was significant pushback, especially in the cloud community. Back then, people would identify as I'm a cloud engineer, like cloud advocate, saying that because there is less guarantees in the cloud, then you don't need the Outbox. All you need is just write your code idempotent and everyone will be happy. That, to me, I'm a bit skeptical here when it comes to some NoSQL databases, but I think that coincided with that rise of NoSQL, no transactions kind of trend, which we know how it ended. Most NoSQL databases have transactions now, so it wasn't like it cannot be done. It was just the kind of zeitgeist thing. But coming back to just make your code idempotent, a counterexample that I like to give to people when talking about that is, a set is a very nice data structure. It has idempotent operations. You can add an element to a set and you can remove an element from the set, and those operations are idempotent. If you try to add an element to a set twice, it will be the same set as if you try to add the element once, right? It just contains that element, and same with removal. But if you think about the operations of a set, both of these operations, and you take into account that you put these set operations in the queue and you might get duplicates and you might get reordering, which always happens with message queuing technologies. You might start with an operation add and then remove. What happens actually at the message processing level is you might have add, remove, add, to which outcome is the element is still in the set, whereas the initial intent was to add it and then remove it. So even the message is, even if you make each piece of business logic idempotent by itself, and that's tricky by itself as a task, then if you allow different pieces of business logic to be executed by the same message processing endpoint, and you allow multi-threading, which is more or less the must, and you take into account that reordering always can happen, you end with chaos always.
With idempotency, is that something that the Outbox pattern is trying to solve? I thought that idempotency would almost be more problematic with the Outbox pattern, because in a way it feels like we've got this problem where without the Outbox pattern, the example we gave before, the order's been created and you're publishing a message saying that the order's been created. So you've got that transaction problem there. But by making a record in the messaging table in your database for a worker process to process, that's then going to publish the message in the worker, then mark the Outbox record as delivered or whatever the flag is. But one of those could fail and one could succeed in the worker process, which I guess next time the Outbox scheduled task or however often it's running, next time that runs, it would then try to publish it again, which might cause the message to be published lots of times. So surely that's when we need to make sure that our consumers are idempotent.
So I think that that's a very valid concern. And maybe before answering that question and adding to what Szymon mentioned, I think that there is one interesting angle when it comes to idempotency and Outbox. So when people are advocating for idempotency, they usually say, you have to solve it in your business code. So write your business code so that it's idempotent. But what it means is that for every message handler and every piece of code that I have in my system, I need to double, triple check whether it's idempotent or not. If I make any changes to that code, or whoever makes a change to that code, they need to double, triple check whether it's idempotent or not. So it's like a never-ending battle and something that you can't really be sure of in the end, especially if you have a bigger team. What is nice with the Outbox is that it becomes or is implemented as a cross-cutting concern. So whether you use Outbox pattern or not, your business logic stays the same. So in my opinion, this is a very valuable distinction, or the value which is brought by the pattern. You introduce it once, you make sure that it's enabled in all of your endpoints, and you don't have to think about it at the business code level. So that's just a side note to what we discussed already. When it comes to the scenario that you mentioned, which is sending out messages a couple of times, I think that the Outbox pattern, at least the implementation that we think is, let's say, the vanilla one or should be used, is making some assumptions about the messaging infrastructure. And those assumptions are that no matter how hard you try in your business logic, you can always get message duplicates and reordering of messages, let's say, on the wire or in between sender and the receiver. So you could argue that the scenario that you described, when you have the, let's say, async worker, which is pushing out messages, it pushed out some, then it failed, and then it tried one more time, and there are duplicates. From the receiver perspective, it's indistinguishable from other problems that can already happen, which is, I picked up the message, there was a network outage, and that message gets back into the queue. And from the logic perspective, it's going to be executed as if it was duplicate. Or I have a multi-threading at the receiving end. So there is an inherent race condition. So it's even hard for us to figure out what is the order of processing. So from that perspective, and keeping that in mind, I think that the way that you can think about idempotency when implemented via Outbox pattern is that even if you have duplicates being sent out, those duplicates are identical copies of each other. So they are basically the same snapshots of exactly the same content on the wire. And idempotency means is that if we push duplicates, they are going to be exactly the same ones without any inconsistencies in the content.
And presumably that's something that a lot of brokers will help you out with anyway.
Yes. So some of the brokers do support functionality, which is deduplication based on identifiers. So none of them support that. Some of them do. However, that usually comes with some constraints. So usually there is a window of time in which that deduplication will happen. So for instance, when you have a situation when a message cannot be processed, it's a so-called poison message, and you need to redeploy a bug fix to reprocess that, you can miss the window of opportunity and the window of the duplication. Secondly, when you go into the scenarios when you start partitioning your namespace, so you are adding more throughput to your namespace so that it's more performant, then most of the brokers stop delivering the duplication guarantees. So in the end, at least my personal opinion is that that should be treated as an additional layer of safety. But in the end, you will need some deduplication, hopefully in form of the Outbox pattern that covers the full range of possible scenarios that can happen in your system.
I still feel like I'm misunderstanding something, because where you're saying then that the Outbox pattern helps this, I'm still struggling to understand why the Outbox pattern helps with duplicate messaging, because especially given the scenario I mentioned before where the Outbox worker, if that fails, that's going to retry the same message, because in the Outbox database table, it's still flagged as not being sent, even though it has already been sent.
I think that's because we both are conditioned to a degree by the implementation that is the most prevalent in the messaging industry, that couples together deduplication and the Outbox in the same data structure in a table. And that's because what you mentioned previously, because that async process that pushes out messages can create duplicates, and it's kind of obvious it creates it. It might be more subtle that retrying messages or multi-threaded code creates duplicates, but the Outbox process, that's in your face. It can fail here. If it fails, it reprocesses. So it pushes people to, we need to think about it on the other side. And the easiest way to think about it on the other side is, I'm pushing out a message so that the other service will be processing that message. I assume that because Tomek mentioned Outbox is a cross-cutting concern, that other service will have the Outbox enabled. So it will create the Outbox record as part of its message processing. The tiniest little change that I can add to that other service to handle the duplicates is, let me add the message ID to that Outbox record. So the Outbox record no longer contains just the messages that go out as part of the transaction, but also its primary key has the ID of the message, the incoming message that results in these outgoing messages. So a single Outbox record connects incoming message with a bunch of outgoing messages. And by keeping that Outbox record as a deduplication record, we can make sure that the async process that pushes Outbox messages and creates duplicates will do no harm to the downstream service, because that downstream service will receive these duplicates. For the first time, it will create a new Outbox record, store the business data, push out messages. When it receives another copy that was generated by the other service's Outbox, it will look in its database and find existing Outbox records. So that's, I think, the critical change that we're missing. It needs to, before going on to process the message, it needs to go to the database and see, oh, there is an Outbox record for that already. So the only thing that it does at that point is, if that Outbox record still contains outgoing messages, that means that maybe they need to be dispatched. And now I think it leads us to this discussing how we can push out these messages, what are the ways. But I want to stress out that ID is not part of the vanilla pattern as Tomek described it. The vanilla pattern is says, let's store the outgoing messages in a database record in the same transaction as the business data, and it's mostly useful on the web frontend. Or to be more precise, that pattern in that vanilla version is useful in the at most once context. So gRPC, HTTP web requests, whatever communication mechanism that doesn't have the automatic retries that would generate the duplicates. When in messaging context, that Outbox record has to contain that additional information about the identification of the signal that triggered it. Otherwise, it will generate chaos again.
So, as Szymon mentioned, and from my perspective, naming things in computer science is hard, and and I think that this is a very great example of that happening. So, I fully agree that the vanilla pattern is the one that we described so far. So, the message comes in, database changes are captured together with the outgoing messages, and then there is an async worker process which pushes out the messages. And I think that what we are advocating is that that's not really enough, because you can get duplicates on the input. So what you want to make sure is in that table that we already mentioned, which is for the outgoing messages, you can also capture the ID of the incoming message. And before doing anything, you can see whether that was already handled or not. And if yes, then you can simply skip it, just to make sure that your business logic does not execute twice. So that's one of the first tweaks, I think, that we would advocate in changing that pattern to make sure that it's more robust and it can handle with larger range of potential problems in your system. Yeah, and I think that also, as Szymon mentioned, there are various tweaks to the pattern, and I think that they come from a couple of different angles on that. I think that and let's call it, for the sake of the discussion, the vanilla Outbox pattern. I think that it comes from the world of synchronous RPC communication. So the assumption there was that you can't really get a duplicate when you receive HTTP calls or gRPC calls or Corba calls or whatever weird RPC you are using. So it's not really that important to duplicate at the input. The situation is vastly different when it comes to messaging infrastructure, because the message will be redelivered until it's act, as we already mentioned. So the duplicates are very, very common there, or significantly more common.
So are we talking about scenario where you're saying not gRPC or HTTP? Are we talking about scenarios where you've got, I don't know, maybe Saga kind of patterns where you've got something that's consuming a message, but then firing another message? Is that what we're talking about?
Exactly. So more as a backend to your, let's say, front end. When you have a website which receives an HTTP call, puts some message into the queue, returns status to the caller. And then let's say that it might be a RabbitMQ if you're working on-prem, and that message is being picked up from the input queue of some background service. And that service is going to update its database and then communicate with some downstreams as well. So that's the scenario that we are talking about, in which duplicates will happen. Like, they will be visible in production.
I guess with duplicates as well, it really depends on what the thing is, and you've got to know the business requirement around it. So, for example, if it was a message that was saying add £1 million to a bank account, you don't want that to be run multiple times. So it's kind of like you'd have to put extra effort into making sure that was idempotent. But like then I guess some other kind of messages, it doesn't matter if it's, say for example, you've got a thermostat which is just publishing the current temperature. It doesn't matter if that gets done lots of times. So I guess you just need to know your business case and how important idempotency is. With you did mention earlier about messages being put in memory. were you talking about the Outbox table? Because presumably that has to be in your database for it to be a transaction, or were you talking about something else maybe I just missed?
So, and I think that that's a detail of Outbox pattern implementation. But basically, let's imagine that you have a message-based equivalent of your HTTP controller. So a bunch of logic which starts with doing some selects, getting records, and then based on the state of that record, publishing some data and then committing the changes to the database. The important bit to understand about the Outbox pattern is that the Outbox pattern cannot let you send that message when the code is executed in your logic. So let's imagine that we are debugging that piece of code and you added a breakpoint when you have like messaging infrastructure.send. You step over that. What is happening is that no messages are being sent to the broker. There is no communication happening on the wire. What is happening is that Outbox implementation is actually substituting calling the broker into temporarily storing those messages into some in-memory representation. And then when you do a commit in the transaction, it basically adds a bunch of inserts so that what was captured in memory gets stored in the database. And then after the commit, it's gonna physically send those messages out. So very common confusion that happens when debugging those kinds of systems is that a developer steps over a messaging infrastructure operation, they go into the broker and see, oh, but there is nothing in the queue yet. Like, what is happening here? And what is happening here is that basically Outbox is doing some buffering, some capturing in memory of messages and pushing them out only after the commit to the database happens.
You can think about it, a good analogy is Outbox in this way is an extension of, let's say, entity frameworks data context or a Hibernate session that adds new kind of operation that is send a message or publish a message, right? So with ORM session thing, you're not interacting with a database as you write your business code. You're loading some entities, changing properties, and everything happens like in memory in Flux. And then once you decide, yeah, let's persist the changes, then you persist them. And hopefully, because you configured your optimistic concurrency correctly, it's either going to succeed and not overwrite anybody else's changes, or it's going to fail because someone else wrote something. That's the same with the Outbox. You're not sending messages immediately, capturing them, and then you're sending them as one big thing alongside with the business changes. So it's going to either succeed atomically or fail. And from the perspective of what can go wrong, it adds one more. If the Outbox has this deduplication mechanism built in, it adds one more failure case is when the message has been already processed by the time you're trying to commit the Outbox transaction, it's going to fail because the record with the same ID already exists. So it could be considered another example of optimistic concurrency failures or concurrency failure, in addition to one that checks the aggregates for their versions as normally.
And maybe to give some intuition from the C# developer perspective, without using Outbox, when you have any send or publish operations in your code, they will be async. You will be awaiting on that because they are involving I/O operation. With Outbox, that doesn't make sense because there is no I/O happening when you are calling that line. It's only storing in memory. So that's, I guess, one of the rule of thumbs that you could use to figure out whether someone is using an Outbox or not, that their sends operation are basically captured in memory and there is no I/O happening when that gets executed in your code.
Are there any variations of the pattern? But presumably, like if you're, when writing to the database, maybe you don't control a database, so you can't add an Outbox table, or maybe your business object is you've actually got to send, your code has got to send a third-party request to create it somewhere else. Maybe just you've not got the flexibility to create a table in your business database called Outbox or messages or whatever. Are there any variations where you can still do this kind of thing? Or presumably you have to have a transaction, so if you can't do that, you can't use the Outbox pattern? Or is there something you can do still?
So there is always some information that you have to piggyback in that committing transaction. Because as Szymon mentioned, the atomicity guarantee comes from the fact that you are at least logically committing the outgoing messages together with the database changes in a single transaction. And then you can think about how much can we carve off from that information that you're storing together with the Outbox, with the business data. And one of the implementations that is there and by the way, I think that we have an example of that in one of our blog posts, is that the minimal thing that you require to be committed is a ID of transaction or a GUID. So what you can actually do is, instead of storing the outgoing messages into your business logic database, you store it somewhere else. Let's say blob storage, file system, whatever. However, you need to have like a handle to that, which is, let's say, a GUID, and then that GUID has to be piggybacked in that transaction. So you can definitely carve off the amount of data that you're storing there, but there always needs to be there. So for instance, one of the techniques that you can use is, if you're using Cosmos DB, you can add custom attributes to your documents. So one of the new custom attributes could be Outbox record ID. And then Outbox gets stored somewhere else, potentially even using different storage technology. But still you have this connecting link between your logic and the business logic data and the Outbox storing the outgoing messages. So that's definitely, there is a spectrum of like how many things you need to piggyback versus how little, but there is always something. You cannot really ever get to zero there.
Oh, that's really interesting, actually, because like even if you're storing maybe not like a Cosmos document or a SQL record, if you're storing like maybe Azure storage, blob storage, like a physical file, you can add metadata to that. So that metadata could be your ID and that kind of thing. Yeah, that's really nice. I like that.
Yes.
The only requirement, I think, is that it has to work with optimistic concurrency, because you don't want to override that piece of information. So as long as you can have a conditional write that says, I want to update that piece of information only if it hasn't been put there before by the concurrent processing attempt, then it's going to work. And it's just one ID or one GUID that needs to be there.
The other tweak to the pattern, which I think is actually pretty common in the messaging libraries, like NServiceBus or Mass Transit, some flavor of that exists in Dapper as well, is that you don't always want to have this async worker, which is grabbing information from the database. And one of the reasons for that is the query capabilities of the business data store. So that async worker usually assumes that you can do pretty efficient range queries. So what the worker is doing some equivalent of a select, which has a range saying those are the oldest, or give me all the outgoing messages that I should be sending out up until this moment in time. And then the assumption is that the data store is capable of executing that query efficiently, which is not always the case. So one way that this can be changed is that instead of having an async worker, which is responsible for pushing out the messages, that responsibility can in turn be put onto the incoming message. So that's also one of the changes. So in that context, what is happening is that when an incoming message comes in, before it's being acknowledged by the receiver, all the outgoing messages are already pushed. And only after that, the acknowledgement is happening. So one way of thinking about it is that the whole Outbox data is being basically partitioned by the incoming message. And incoming message is like a pumping or responsible for pushing out those messages. So it's basically this redelivery functionality which comes in from the broker, which is responsible for pushing out the messages. And then we want to have information about outgoing messages only for a single incoming message, which means that from the query perspective, we want to query only by a single ID. And then the guarantees that the store should provide us are pretty light, because any key value store, when you can query by the primary key, is enough. So that's one flavor of that. The second flavor is the Outbox, which is implemented in HTTP context, or on the, let's say, border between HTTP and messaging. And Szymon, maybe you can describe like what are the twists there, so that it's not only me talking.
Okay.
Sorry.
Sure. The interesting case that Tomek mentioned is that when designing business logic that sits in, let's say, a HTTP controller, you still want to have atomicity between saving the data and sending out messages. You don't want to have the logic that needs to figure out, have I published the messages and so forth. So Outbox, the vanilla Outbox makes sense there. But then that vanilla Outbox sort of assumed that there is this background process pushing out messages. And that became more and more complex with, let's say, serverless technologies, where that background process is not a background process, but has to be maintained as a separate batch job or however it's called, cron job. Then the second problem is that if you're using a partition store like Cosmos DB, then there's no efficient way of implementing that's what Tomek mentioned. So one way of dealing with that problem is to push the burden of retrying publishing of these messages from the Outbox to the client itself. So if you control the full stack and you control the code running in user's browser, you can be clever and say, okay, when I send this HTTP request that is going to my controller, if I receive some sort of error, then I will retry calling that HTTP endpoint again and again until it acknowledges. So that's the responsibility of the client. It's probably not the best option though, because, well, the user can just kill his browser or her browser and the message is stuck in the Outbox, right? So that's probably not the best way of dealing with it. One other way of dealing with it is sending a message to yourself that you want to push the Outbox. So the pattern looks like this. You receive as API endpoint or HTTP endpoint to receive a request, and you start writing business data and you start writing the Outbox transaction, but before you commit that Outbox transaction, so everything is now in a database but not yet committed, so you can just roll back and there will be no trace of it. Before you commit that, you send to yourself a very tiny, we call it control message. Control message is a message that doesn't contain any payload, just a message that says, I want to dispatch the Outbox for that transaction, and you send it to your input queue. Even better, you send it through some sort of delay mechanism to your future self, let's say to yourself in 5 seconds. And then you commit the Outbox transaction. And what happens next is that message shows up after 5 seconds if you have that delay infrastructure. For example, Azure Service Bus allows you to send a message to yourself in 5 seconds. Message shows up in 5 seconds, loads that Outbox record and pushes out the messages to their destinations. So that's what happens. And if the Outbox record is not there, what could happen? Well, your commit to the database that you wanted to do just after sending that control message might take a long time. You might get paused due to GC collection, or the database might decide to be super slow. So the message shows up in 5 seconds. There is no Outbox record. It's not yet committed. So what you can do is postpone by 5 seconds again and go to sleep again for 5 seconds and again and again. But eventually you need to give up, right? You can't reprocess that control message forever because it costs you resources. So let's say after 6 times, meaning 30 seconds, you say, there is no way that transaction is going to ever commit. My Outbox record is simply gone. But at that point, you can't just drop that message on the floor because your database might be just super slow and will commit that transaction in, let's say, 45 seconds. So you need to prevent that. So before dropping that message on the floor, you say, okay, I'm going to create a tombstone that has the ID of that Outbox record that might be created in the future to prevent its creation in the future. So you create a tombstone, drop that message, and if the database transaction was super slow, it's going to fail now anyway because you created that tombstone. If it was gone already, then it was gone already. So to summarize, the effect of that pattern is that you will either get an error or the message will go out and the data will be stored. So that's useful because there is no partial failures there. If it's an error, then it will be sort of a timeout error. You will receive it after 30 seconds. But that's fine. The users will deal with that because we taught them how to deal with unreliable software for the last 20 years at least.
And maybe an interesting note here, this pattern can also be hidden in the insides of the infrastructure that you might be using. So for instance, Dapper is using exactly that. And the reason why it's doing it, and this is to some extent my guesses here, but bear with me, is that Dapper is deployed as a sidecar to your application. And the API between your application and Dapper sidecar is HTTP or gRPC. So this is exactly a situation when you have an API which is not message-based, but you want to have a Outbox-like behavior, And Dapper, for what I can tell, is doing pretty much exactly what Szymon was describing, which is it's using this synthetic artificial control message, which is then responsible for pushing out the Outbox record messages or creating a tombstone record to make sure that the transaction never commits.
Just to clarify for the listeners, because we're talking about databases and we're using the term Dapper.
Oh, yes.
There are two technologies called Dapper. One's DAPPER, which is a database ORM thing. We're not talking about that. There's something else, DAPR, which is more like, as you say, it adds sidecar containers to your application and it just gives you extra functionality. But I just wanted to clarify that for the listeners because they pronounce the same, which is really annoying. I think when DAPR, when Dapper was first introduced, that must have been so frustrating to the author of the database, Dapper.
Yes. I think that naming is hard. Like definitely, we already get into collisions when it comes to good names. There is one interesting twist that you can add there as well when we are talking about different flavors of the Outbox implementation. So far, what we've been describing is changes to the database and outgoing messages. And we can treat it as a side effects of the processing of the incoming request. But having the Outbox, which is HTTP compatible, let's call it, what we could also say is that the response that we are sending to the client could be seen as a kind of a side effect. So if you are returning back JSON from that request, you could say that JSON is actually pretty similar to sending a message on the queue. So why don't we capture that as well? And then when the HTTP request comes in, and we control the client and we say, please use stable IDs so that we can identify like retries. Then based on that ID, we could actually take exactly the same JSON that was already generated without executing any business logic and just return that JSON. So we can have the idempotency also from the perspective of the content which is returned to the caller of HTTP call. So one more twist to the story here.
Yeah, that makes sense. And then you get the caching benefit as well, because it's kind of like the second, any future times, it's just returning the data straight away. Yeah, that's quite nice. With the with this Outbox table, what do you typically see people do for retention for that? Do they have something that clears out process messages straight away, or do they keep them for auditing purposes? What pattern do you tend to see?
That's a very interesting question, because that's one of we didn't really talk so far about the trade-offs of the Outbox pattern. And when it comes to it's not all unicorns and rainbows. The major trade-off that you have here is that you need to, in the vanilla pattern where you just store the messages and then have the process to send them out, you can delete them immediately, those Outbox records. So that's fine. But in the messaging context where you use this Outbox record also as the duplication mechanism, you need to keep them around. So first thing is you can remove the actual message payload from the Outbox record as soon as it's dispatched to the queuing mechanism. So that's one reasonable thing to do. So what you're left with is a database record that just contains the ID of the incoming message and possibly some Boolean flag. So that's a very tiny record, first of all. And then, as you mentioned, yes, you need to keep, if you're using it for deduplication purposes, you need to keep it around. I want to circle back to your auditing question again. So in order to have auditing, you will have to keep these messages inside that Outbox record. So that costs storage space. And that's, if auditing is important for you, then I think that might be a good choice, because that's the source of truth, right? Based on these Outbox records, the messages were generated that were sent to the messaging queue. So if your audit needs to be as close to the source of truth as possible, then the Outbox is that thing. But if you don't use it as a kind of auditing mechanism, then you can remove these messages from the Outbox records, just keep the IDs. I can mention one default that comes with NServiceBus. I think it's 7 days of retention there. And I would like to circle back and compare it to, I think one of you folks mentioned that some message brokers like Azure Service Bus or SQS have a built-in deduplication mechanism. And I think that by default, one of these technologies is the deduplication window is 5 minutes. So when it comes to message duplicates, of course, the probability of a message duplicate in the time axis, it's not uniform, right? It's much more probable to have duplicate messages that are seconds apart than ones that are weeks apart from each other. So there is this reasonable point after which you don't need to store the duplication information, or it's reasonable to assume that the duplicates are super unlikely after the fact. I would say that 5 minutes is unsafe. I wouldn't deploy to production system that has a 5 minutes of the duplication window. The default that comes with NServiceBus 7 days, I think that's already reasonable because it allows a lot of time for the infrastructure to go down and be repaired, improved, and so forth. So that's a good one, but there is no science behind these 7 days. If we're living in a different world where someone came up with an 8-day work week, I think initially after the French Revolution, they created a 10 days work week at some point that they dropped afterwards. If they were more successful after the French Revolution, then maybe the default Outbox duration in NServiceBus would be 10 days, but it's 7 days.
Maybe one note here. So in the implementation of the Outbox pattern, what usually happens is that once the messages are sent out, they can be removed from the Outbox record. So the behavior that you can see at the database level is that you start with a pretty beefy Outbox record that contains the outgoing messages, which immediately gets shrunk because those messages are being removed. And the only thing that stays there is the deduplication part, which is the ID of the incoming message, which is, I guess, an advantage. However, it comes with the disadvantage that I'm going to mention while we are talking about the trade-offs, is that that's pretty unoptimal pattern when it comes to dealing with the data in your database. So creating, let's say, a row in your database, which is pretty wide, and then shrinking it back, that comes with some problems when it comes to how the pages are being, or what is the layout of the pages in a SQL database. Do you want to do defragmentation? Do you want to somehow influence how the pages are being allocated? So implementing that in a reasonable way is not that trivial. There is some, let's say, science and some heuristics which comes into that to figure out what is the proper behavior, which also connects to another downside, or maybe characteristic, I would say, which is getting the implementation right is pretty non-trivial. So I think that it can be described, the pattern, in a minute or two after someone has the enough context. But then getting all the details correct, which is what is the proper ordering of the operations that we mentioned, how the structure of the Outbox record should be constructed, how it should be different when it's SQL database versus document database. There are very non-trivial intricacies that go there. And if there is one single thing that I would want the listeners to get from the podcast is don't implement it yourself. Use a library which is implementing that, because getting all the rough edges ironed out is actually very non-trivial.
Because I guess as well, like just thinking about all the extra stuff involved, there's not just the implementation details, there's also, from a monitoring point of view, you need something to monitor the Outbox table to make sure nothing's like stopped and stuff. So it's just yet another moving part, I guess, where it's more complexity.
Exactly. So there is one more moving part. One additional thing that is worth mentioning, this scenario that you brought up about the IoT, which is Outbox is not needed in every context, and there are always trade-offs to take into consideration. If your system can deal with duplicates or some messages being dropped, like don't use Outbox, because the penalty that you pay for the Outbox is additional state, which comes with the monitoring consequences, but also with additional rights to your database. So processing of a single individual message is just less performant than otherwise. So there are definitely trade-offs with the Outbox, but from my experience, and Szymon, please correct me here, I think that the business applications or business solutions, microservice-based systems that are using RabbitMQ, Azure Service Bus, or some messaging infrastructure, they are usually the sweet spot for Outbox. When you want your team to focus on delivering business value, modeling the business processes, and not dealing with the infrastructural plumbing.
The rule of thumb that I like to use is to distinguish the business messages from data or from signals, events, is that a business message has a value on its own, versus if you're into event stream processing, each particular event, like a temperature reading, doesn't have value on its own. A pattern that is in that data that can be detected has value. So we would like to think about it. There's a stream of events that is temperature readings. There is probably no value in having Outbox there. If you're missing some temperature readings, that's fine, as long as you can detect the pattern that is valuable for you. So if you're missing too many of these temperature readings, that's also bad. But I think there are different patterns in the event stream processing space that deal with having enough reliability to not lose too many additional individual events. And then you detect some pattern, like the ravioli oven is too hot, and that becomes a business significant event. You publish that event to potentially a different medium than you used to transport each individual temperature readings. And that's business significant event that I would say whenever you process that, it's worth the hassle of implementing the Outbox and having that additional write and dealing with that background process, because you don't want to miss that fact, and you don't want to have that fact being considered twice because it got duplicated.
Nice. So I'm aware we are almost out of time, and I know we wanted this episode to focus on the Outbox pattern itself, but I'm also aware you're both from NServiceBus and you're giving up your time to do this. So let's talk about NServiceBus from an Outbox pattern perspective. If I'm using NServiceBus already, but I'm not using the Outbox pattern, if I want to turn it on, is it something that's just a case of turning it on, or what does that look like from an NServiceBus point of view?
So it's pretty simple actually. So it's a one-liner which is .enable Outbox. There is obviously some magic which is happening behind the scenes that we described to some extent, which is we will make sure that the messages do not go out immediately, that they are captured, that they are piggybacked on the business transaction that are executing in your system. And the consequences are also that some tables will be created in your database and if you're using Outbox, or some additional documents are going to be stored if you're using Cosmos DB. But long story short, it's pretty easy. Thankfully so, the model of NServiceBus is so elastic that from the user perspective, you don't really see a difference. If you had a system written on top of NServiceBus without an Outbox, that's pretty much only a configuration change or the one-liner change plus some additional infrastructure or stuff that then you need to watch out for.
Yeah, it's so easy because we decided at some point to restructure the internals so that the Outbox is the default behavior. Or basically, the Outbox behavior is the only behavior NServiceBus can do unless you explicitly tell it to do otherwise. And the default implementation is just in-memory implementation. So by default, when you have a message handler code and you send messages, these messages don't go out. They are captured, as Tomek mentioned, in memory and sent out after your business logic completes. If Outbox is disabled, there is no backing store for them. They are immediately sent out afterwards. The rationale behind that is it's still safer to batch them together and send them after the code executes than whenever you decide to call .send or .publish, because there is less partial failures that you are exposed to when they are batched together versus, oh, let me write this in the database and then send one message, and then let's write something else in a database and then send another message. There is so many failure points in that code that we want to shield users against it, unless they really want to. I want to send that message immediately because I know what I'm doing. That's also possible, but that's a different, let's say, sending path.
So as an example, if you've got a consumer and you're using Entity Framework in your code, so I've got a consumer method in there, I'm injecting into my class data context for Entity Framework, and I'm writing my business object, order, whatever you want to call it. How does the NServiceBus Outbox pattern know about that data context to wrap it in the same transaction or put it in the same database?
So there is a piece of code that you need to add to configure what we call in NServiceBus persistence. And in that case, would use SQL persistence that can be integrated with Entity Framework. So SQL persistence is a way of NServiceBus dealing with storing the Outbox. And in that specific case, you would have to give up the creation and the destruction of the Entity Framework data context to NServiceBus and say, hey, NServiceBus, when you need to have a data context, here's how to do it. So you still have the control over which specific type of data context to create and how to initialize that specific data context thing. But NServiceBus will take over the responsibility of figuring out when to create that data context, when to open it, and when to call save changes on that data context. And it will make that data context available for you in the DI container. So once your handler gets resolved from the DI, you get your data context, you get your messaging context, and it's all wired together for you. But you need to specify that. So that's the piece of code that a framework can't do for you, because you're dealing with entity framework as one thing, one library, and service bus as the second library. There's no dependencies or no obvious way of these two parties to work together, at least not aware of. Microsoft doesn't want to do what we tell them to do. Well, joking now, but the user needs to integrate these pieces of infrastructure, and that's kind of 3 lines of code that sits in a single place in your code base. So.
Yeah, that makes sense and sounds quite easy as well. So that's quite good. For NServiceBus, do you have any like stats from, I don't know what kind of telemetry you get of projects that use NServiceBus that are using Outbox Pattern versus ones that aren't using it?
That's a very good question. I don't think that we have those stats that are. So we track information regarding our customers when it comes to what kind of messaging infrastructure they're using, not about features to that level of details. From my experience, most of the customers do use Outbox. I think that I would treat it as a default. So usually I am surprised when they are not using the Outbox. So I think that the amount of customers who do use it is probably majority. At least that's my guess.
I guess a lot of it would be like just education as well. Like a lot of people are like, there's lots of things talking about like talks and content on the internet talking about messaging and the benefits, but then maybe people have started to use that in their code bases, but maybe haven't got as far as things like the Outbox pattern and even just mentally understanding like the stuff we've discussed today. So yeah, maybe it's just an educational piece. I've definitely seen a lot of code bases that just use messaging, but not many that use the Outbox pattern. But I guess that's the advantage to using something like NServiceBus, where in a few lines you can just like air quotes turn it on.
Yes.
Yeah, I think one reason why people might not be so easy and straightforward for people to adopt the pattern is that I see still when talking to people that there is this persistent pattern people have in their heads that you should decouple the abstraction for consuming messages from the abstraction of sending messages. So you go to a code base to review the code base and you see that there is message consumer and a message producer abstractions there in a separate places, sometimes in a separate libraries even, for the sake of decoupling. And there is this kind of common knowledge floating around that you should decouple these. And the Outbox pattern is cross-cutting here. It's just sits between these, and the Outbox pattern, when you see it, especially in the messaging context with deduplication, it says you cannot have decoupled message producer from message consumer because it's one single operation that consumes a message that produces a bunch of other messages and stores some data. And because it's one transactional unit, like at runtime, it cannot be separated in a design time to different abstractions. So getting through that is the first step of, hey, these are different sides of the same coin. There are not different things, different processes that you implement. And once you're on the other side of that mental shift, then it's, I guess, easier to adopt or to even imagine that you can adopt a pattern such as this one.
That makes sense. So time-wise, we are going to have to wrap up, which is a shame because I could carry on talking about this for hours. This is really, really interesting. Did you see it in the guest FAQ about dev tips at the end? I'm not sure.
Yes, I was actually thinking about one, which is which is pretty wild. So one thing that I'm recently into and considering is something which is called the G0 flights, which is basically parabolic flights that you can take. So money aside, which is a problem in that context, I recently discovered it and found it very interesting because what you can do is you can have, I think, 12 rounds of parabolic aircraft going down on a parabolic route, which means that you experience basically 0G, as if you were in space. So that's my recent discovery that I wanted to share.
So have you had a go at that?
No. So I have that in plans, like fingers crossed, should be able to do it, but not yet.
So what's that called? I'm curious
about that. I think the company is called 0G. I think it is a spin-off from European Space Agency, and they used to do flights from France. However, they moved to US recently. So the only way to do it right now is actually to travel to US and then take it from there.
That looks awesome. I'm not sure whether I've mentioned on the podcast before, but this was many years ago now. I had a phase of where I was really into skydiving. So I did that for about 3 years, pretty much every weekend. And then, I'm looking at these pictures now of everyone just floating in planes, and it just brings back lots of memories. It's not quite the same thing, but yeah, you've added another thing to my bucket list. That does look awesome. Did you have a tip, Szymon?
Yeah, I guess I would. Okay, that would be related to our topic, but I can't not add it here. As we spent this hour discussing Outbox Pattern, and most of it, or a significant portion of it, discussing how to deduplicate messages by keeping track of what messages we processed so far. But I want to just tease the listener's brain and push listeners to think slightly outside of the box. The biggest problem with the Outbox Pattern is that we need to keep this Outbox record around to figure out, have I processed this message for a week like we discussed, or maybe for a month? It takes space, it's cumbersome, we need to deal with the operations people who want to delete it, and how to delete it, there's no good option. So how about you think about it, and that's kind of homework / food for thought. How about you think about the process of, instead of keeping track of messages you processed, you store somewhere information about messages that need to be processed. And once a message is processed, you delete that information. So the amount of information is proportional to the number of in-flight messages between any two endpoints, not to amount of messages processed by any single endpoint. Can this be done? How to do it? Is it an improvement to the Outbox pattern?
There you go, listeners. You've got homework, answers on a postcard. That's a good time to remind everyone that every single episode on the website has a comment section at the bottom. And we don't really get that many comments, so I just want to encourage listeners to actually head over to the website and comment on episodes that you listen to. So my dev tip is it's not a dev tip, but it's a general tip for, I found that I'm reading a lot more because I've started using a service called Readwise, and it's really, really good actually. So there's two aspects to it. There's one where you can just, if you've got a web, like say you're reading an article about something, you can highlight, or in your Kindle, if you've got a book and you take highlights, it syncs with Readwise. So you've got like a big database of all your highlights across all your different things. But then there's another aspect called Readwise Reader, which is kind of like a read it later service. So any article you're reading, if you write, whether it's a blog post or whether it's technical documentation or something on the news or anything you're interested in, if it's in a browser, you can right click and say save to reader. If you're on your phone or you're, let's say, on a social app like Twitter or Blue Sky or something, you can share it with Reader, so it goes into your reading list. And you can tag things. There's all sorts you can do to it. And there's a desktop app, a web app, mobile applications. I've got a e-reader called an Onyx Books, BOOX, and I can share these links in the show notes. And it's like a Kindle, but it's an Android device. So it's got the paper screen with the e-ink screen, but it's Android, so I can install the Readwise app on there. So I do a lot of reading on that. Any links in articles I see, which it's like I'm reading a technical article and there's a hyperlink to another article that's related, and I find that interesting, I can click on that and say add that to Reader, and then carry on reading that article. So you end up just building this massive magazine, this massive database magazine of stuff you want to read. And because I've got this books device, I'm just reading so much more stuff. So yeah, that's my dev tip. I'll include links to like Readwise and the Onyx Books in the show notes. I'll mention this as a dev tip because it's awesome and I'm using it a lot, but I will do not an affiliation link, but basically I can do an invite link, which I get an extra month free. And if you sign up for it for free, you get the free month and an extra month because you use this link. So I'll put that in the show notes as well. But again, I'm mentioning it because it's awesome, not because of that link thing. So that's my tip. Sorry, that was quite a long one, but...
Oh, nice. Thank you for sharing.
So I know a lot of this is an audio-only podcast, and a lot of the stuff we've spoken about today probably is helped by diagrams or something visual. Are there any recommended resources you would point the listeners at that we can put in the show notes that would help explain the concepts we've discussed today?
Yeah, so I think that there is our blog post. So we have a bunch of articles on the insights of the Outbox, deduplication, and consistency. That gets pretty much in the very details of the pattern. I would also recommend a summary post by Oskar Dudic, which goes into the implementation, specifically in the context of PostgreSQL, but a lot of the things that he's talking about there are pretty generic. I think that there is also a presentation, video one by Jimmy Bogart about consistency in distributed system, which goes through over the Outbox pattern that I would also recommend. So we can definitely add those to the notes for the show.
Is the Jimmy Bogart one the one that was at the NDC that we've just met,
Yes.
where we met actually?
Yes. So today is the beginning of March, and we are so lucky that I think 2 days ago it was actually published. So I wasn't sure whether it's going to be online before we meet, but it is there. So I can recommend it. Yeah, it's available on YouTube.
I actually saw that in person, and this made me realise, because a lot of the stuff he'd spoken about in his talk was also comparing with the two-phase commit, the 2PC pattern. And so he was talking about that a lot, and I realised we've not actually covered that, but maybe that can be another episode.
Yes.
Brilliant. So I'll include those links in the show notes. And yeah, with that, thank you so much for joining me on the show.
Thank you very much.
Thank you.
It was a pleasure. It was a pleasure. Very, very nice talking to you.
It's been great fun. And thank you everyone for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you enjoy the podcast, please do help me spread the word on the socials. I normally use the hashtag unhandledexception, and I can be found on Blue Sky at danclark.com. But the best place to reach me is on Discord, and the Discord link can be found on the website, as well as everything we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.